Katy's got some really exciting new results on behavior change, and I think that's generally what everybody comes here for anyway. I will be doing the moderation of the Q&A, and Katy, I guess I should introduce you, but I'll just say Katy is my academic sister and BFF, and she is the fearless leader of Behavior Change for Good. And also a mom and also like a terrific person. So without further ado, if you don't mind, Katy, I'll disappear to mute my video and you'll take it from here.
I will, if I can remember all the things I have to do. Yeah, let me share. Thank you for the very kind introduction, Angela. Okay, so today I'm going to share some work that I did with so many people. You probably won't have time before I exit the slide to see all their names. Angela was my main partner on crime on this, plus all the staff at BCFG, the amazing BCFG staff, and many brilliant scientists who are part of our team. And you'll see how they contributed in a moment. But I will just say this was the most enormous team effort I've been a part of, and it was really exciting. And as a preview of what I'm going to do today, before I dive in, I'm going to tell you about a new approach. We call it the MegaStudy Approach to doing applied behavioral science. So I'm going to start by describing this sort of method, this new kind of scientific method. Then I'm going to tell you about a model project that we did with 24-Hour Fitness. So there will be data, there will be results. It's not just a talk about a new method. We're actually going to share an example of it. And at the very end, I sort of teased this when I tweeted today. I will talk about ongoing work just very briefly. We don't have results yet to share, but we are doing work this fall on vaccine encouragement, hundreds of thousands of people in a study just of this type that we expect to have results from in time to influence COVID-19 vaccine take-up, hopefully. So we were really excited about the news this morning about the great vaccine, as I'm sure all of you were too, waiting for the safety results, but excited and hoping the work we've been spending a lot of our time on since COVID struck is going to end up being really valuable to help encourage vaccine adoption. Okay, so let me get started. A MegaStudy Approach to applied behavioral science. Why do we care about applied behavioral science? Well, this is quite a day to be talking about government, because there's going to be a transition of power. It's been a big weekend for that. So in government, there's increasingly been an interest in behavioral science over the last decade. People are around the world leaning on behavioral scientists to figure out how we can nudge people towards better decisions. There's been this huge rise in the last decade of nudge units, and this is a great slide from actually a couple of years ago that's out of date, showing hundreds of nudge units that have sprung up around the world as a result of the work Thaler and Sunstein pioneered on the importance of using behavioral science to encourage better decisions. So there's just tons of appetite for applied behavioral science solutions to policy problems. But how do we get those good solutions? Well, I think it's pretty widely agreed that policy advice ideally should be based on field experiments, since the lab is really a place where we're intending to measure whether or not something is true, not whether or not it matters in the wild. And it's only in the wild that we can find out if it matters and how much and how cost effective it is and so on. But running field experiments has really large fixed costs and is also very slow. So once you have an idea, maybe you test it out in the lab and you want to take it to the field, this can be a very long process of validating it. In addition, even when we have field studies to look at, looking at effect sizes across studies often requires us to make apples versus oranges comparisons. So a lot of the best retirement savings nudge study data is out of Europe, for instance, and then, but then you have a new study that crops up in Arizona with a totally different population, and you try to say, how do we know, like, how to compare the cost effectiveness of these different trials with these very different populations? So that's a challenge. The replication crisis also affects the important work that's done in this arena. So it's not always clear which behavioral insights will be robust as a result of this. And because of the file drawer problem, meaning people not publishing null results, we may expend huge amounts of resources to try to replicate others' failures without knowing it. There's a great paper that's a working paper out this year by Stefano Della Vigna and Liz Linos, suggesting that the average effect size of trials out of the behavioral insights team is significant, it's a few percentage points in terms of behavior change. So it's exciting, but maybe not quite as big as what we often see in the literature when people are just publishing the big successes. Okay, so what's the solution to all these problems? Well, today I'm going to propose that it is to do a new kind of science to try to run mega studies when we can. A mega study is a very large field experiment in which many smaller sub-experiments are synchronously run with the very same dependent variable. And I'm going to be really clear by giving an example, but basically just like a really large field experiment. Instead of having, 2 experimental conditions, you have more like 50 experimental conditions and many hypotheses tested simultaneously. The benefits of this approach are many, but let me highlight a few that I think are particularly exciting. One is it allows for comparability of results across studies. So this apples to oranges thing that I was just mentioning goes away. Now we're making apples to apples comparisons. The fixed costs of executing the study can all be borne by a central organizer, and it really lowers the marginal costs for individual scientists. It reduces risks of learning nothing useful from a costly field study, because now when you're running many things, even if you Bonferroni correct, it's very unlikely that nothing will be effective. And it also eliminates the file drawer problem because you can publish all of the results together, and the nulls are just as interesting in that context as the successes, whereas often null results are never published. You can run it with interdisciplinary teams as a tournament, which is great. So if you have many studies all run at once, you can have your economists who sort of want to publish in their journals run their study over here, the psychologists over here. They can each publish separately, but they can also see what each group came up with. And also behavioral phenotyping becomes possible. So this is a like nerdy medical term for basically figuring out what works for whom. And normally if you run a study with just say one hypothesis you're testing and you say, oh, like it worked better for women than men, but you don't really understand, all you know is this study worked better for women than men. If you tested 20 different interventions, now you can find out like which one is the very best for women, which one's the very best for men, and other subgroups and so on. So that's exciting. The wider your trial, the more experimental conditions, the more you can do this phenotyping. And finally, it just vastly accelerates the pace of scientific discovery relative to the usual one-at-a-time processes we're used to. Okay, I want to acknowledge that there is actually precedent for this being a really productive way to do science. There, to our knowledge, is not research on mega study type work in the social sciences exactly, but in AI or machine learning, this has really revolutionized actually the field using what's called a common task framework. So in that arena, you would have researchers competing to solve the very same problem, say image recognition, subject to the very same constraints, like the exact same measure of success. How good was your image recognition? Well, like here's what's ground truth, and we're going to compare what you came up with to ground truth, and they'd use the same data set. So everybody's working with the very same data set to see how good is their algorithm at doing image recognition, and they all have the same metric to determine. And now you can really see, oh wow, like this algorithm really outperforms these others because of that common task framework. And so we're trying to bring that idea really into behavioral science. It also is related to scientific tournaments, which have come into social science and have a similar flavor, but they don't have random assignment as an element of them. So there's not that same kind of comparison of what's working well. Okay, so let me tell you about our model mega study. This is a project we did with 24 Hour Fitness, which is a 4 million member gym chain it had 430 US locations at the time. Obviously, this is a difficult time to be in the gym business, so things have changed a bit since we ran this study. And I'm going to start by giving you a rationale and study goals. This is just an overview to give you a sense of what I'll cover. Obviously, we don't have tons of time. I'm going to go until about 25 after and give you a high level, and then we'll have time in the questions to go into some more details that you guys are interested in. So just really quickly, a lot of people say, like, why would you choose physical activity as the first thing you'd study? Why not, like smoking cessation or diet, or if you're in health, or education? We have done mega studies, actually, a little mega study work in education too, with Angela's nonprofit Character Lab. But I just want to point out, actually, physical activity is a really important behavioral problem. So only about half of American adults exercise sufficiently. Exercise has all sorts of benefits, not only for mental health, but physical health. And 9% of premature global mortality is due to insufficient physical activity. So it is a really important problem, but it also has this really nice feature that we can measure high frequency decisions objectively. Unlike what you eat or whether you smoke, we have this really nice measurement. Every time you enter a gym that requires you to use an ID card for access, we know. So it's a favorite of behavioral scientists studying behavior change over time. And there's been a lot of past research on gyms, so that's also nice. We can look at how our results compare to that to some extent. There's research showing that big rewards for repeated gym visits over 4 weeks can be quite effective. And I actually was a part of a paper published earlier this year led by John Bashir's, where we ran a study at Google. Here I'm showing you a graph of our results where we ran an intervention also for 4 weeks, and that's what you can see on the x-axis before the line. It says during intervention, where the treatment group got a prompt to make a plan for when each day. They received reminders by text or email to do that right before their scheduled workout, and they got small rewards on the order of magnitude of a few dollars every time they went to the gym. And you can see not only did that work during our treatment period, but actually it endured. The results lasted about 40 weeks after. So we wanted to build on this work. It seemed like a really fruitful problem domain. And we ran a mega study where 30 scientists designed 20 different pre-registered research studies with 53 different experimental treatments. And the researchers in this sort of tournament style mega study could vary a few elements of the experience that people had. So they could vary a sign-up experience where people registered for our exercise boosting habit improving program. They could give people incentives for exercise or other things they did during the program that were measurable. They could send reminders and interactive texts to participants, and also weekly emails for a 28-day period. We had a holdout control group or a placebo control, I'll explain in a minute, but we also tried to use sort of best practices as a comparison. So in addition to having a holdout group that basically didn't get any treatment, we had a treatment that mirrored what we thought we'd learned from past research would be effective. So prompting people to make a plan about when they'd exercise, sending them reminders, and giving them very small incentives, order of magnitude 20 cents for every gym visit. And then we tried a lot of other things too. And if you're like trying to read all of this, you will get dizzy. So don't. I will highlight some big winners in a minute, but this is just a smattering of ideas tested. Okay, so how did we do this? We recruited people for nearly a year. All 24-hour fitness members were encouraged to register by email, for push notifications on an app. We even had some in-person marketing happening. They got postcards and there were posters up in gyms. They were encouraged to register for a program designed by scientists to create exercise habits. We had a nice website I'll show you in a second. And in the end, we recruited about 63,000 participants to our sample. They were 64% female. They'd been gym members for a while, so we weren't getting mostly fresh members, a little heavy on the California location, because that's where 24-hour fitness is big. And these are not people who'd never been to the gym before. So, take all those things, those all are limits to generalizability, but it's not like these are people going 7 days a week. Okay, so here's how study registration worked. People went to a website, often on a smartphone, because they're at the gym maybe finding out about this and they decide to register there. They go to a landing page that looks very professional. We got professional designers to do this. They consent to be in our research. The step up to program terms is actually also a consent form explaining this is a research project. They sign up by giving us their name, their email, and their cell phone number so we can communicate with them. We validate those, and then they're randomly assigned to experimental conditions. So after that enrollment, the group that's sent to our placebo control condition is basically congratulated for signing up, told that they've earned a small amount of cash that we'll send them at the end of the program, and that's all they hear from us. And the reason we did that cash transfer, we wanted people in our placebo group to get the same size payment as we expected to give to people in our other treatment groups, so that we could rule out somehow gift exchange as an alternative explanation for any results. So that's our placebo holdout group. Everybody gets paid at the same time after the program's over. This is what it looked like if for most other participants. Everyone else ended up being informed. They would get repeated rewards based on past research suggesting this would help. So they'd earn points every time they went to the gym, convertible for Amazon Cash. Some people varied the value of those points a bit, but on average, or typically, they were worth about 20 cents a gym visit. So not big time cash, just a little. Almost everybody in all conditions planned the dates and times they intended to work out. So they then get text message reminders to exercise before those dates and times for the next 28 days. And then scientists could insert extra content here, like a survey or a video or, really whatever they wanted, instructions. They could also vary the instructions on those prior pages. And then they're congratulated and sent on their way. They got text message reminders before every gym visit, and then reinforcement of whatever the treatment condition is that they're assigned to if they're not in our control group. So for instance, one of the treatments designed by Ayelet Fishbach and others was encouraging people to try to make exercise fun by doing workouts they really enjoyed. So their reinforcement would look a little bit like this example, saying things like, hey, when you last went to the gym, did you do the exercise you most enjoyed? If they say yes, you say, oh, that's great, keep it up. If they say no, it would encourage them, hey, don't forget, that's really a great way to make workouts something you look forward to. And there'd be reinforcement in the emails received weekly as well of whatever treatment condition people are in. Okay, so let me share some results. First, I'm just showing you our placebo control condition, the group that basically got no treatment. Just before, after, you can see on the left side of the graph is weighted average weekly gym visits before the treatment and during the treatment period. And you can basically see like nothing changed as you'd expect. So like this is our control condition, it didn't do much. And all the comparisons I'll show you will be, all the analyses are sort of compared to this control condition, but I'll also show you these just simple graphs of the average effects before and after relative to each treatment relative to itself. Okay, so this is the first complicated graph. This is the key results graph. I do not expect you to read everything that's on my y-axis. If you do, you'll fall over and get dizzy. The x-axis is showing you a point estimate from a regression we ran that had all of our different treatment conditions in it, a point estimate of the average increase the treatment induced in weekly gym visits relative to our placebo control condition. So our placebo control, again, basically got nothing. They like signed up and then we told them we'd pay them some money at the end and good luck. So what's really nice, if you just look at the dots, what you can see is almost all of the dots are to the right of our control, meaning almost all of our treatments had an estimated treatment effect that was larger than 0. None were significantly negative, and 45% of the treatments outperformed our placebo control at a p-value of 0.05 if you don't adjust for multiple comparisons, which obviously is problematic, but I'm just showing you standard errors unadjusted right now. So we would expect 2.5% just by random chance to work. So the fact that 45% did means probably we had a success rate around 42%, really increased gym visits, and then 2.5% you could assume were just noise. So this is pretty exciting. So a lot of things worked really well to increase gym visits, and I'll highlight what some of them were in a minute. The other thing I wanted to flag is that just our simplest, sort of based on past research, planning, reminders, and small incentives, was sort of a little below the middle of the pack. So that sort of replicated basically what we'd expect from past research, pooling things we knew together at very low cost because we did smaller incentives than previously. And it boosted gym attendance about 9% during the treatment. And 9% actually of the treatments outperformed this significantly. So it was actually hard to do a lot better than sort of best practice, but a few of our treatments did. Okay, so let me highlight a few of the treatments that worked really well, that actually, all the ones I'll highlight today did beat the sort of best practice controls at a significant, to a significant degree, like p-values less than 0.001 without adjusting. The first big winner, the best performer of all of our treatments, increased gym visits by 27% during the 28-day program. And all it did was encourage people to come back if they'd missed a scheduled gym visit by increasing the incentive they would earn for that next gym visit very slightly. Not enough that you'd want to skip. It's just 9 extra cents. So instead of earning 20 cents for your next workout, now you'll earn 29 cents if you come back after a miss. And the idea there is basically just to prevent people from sort of falling off the wagon, having a bunch of missed visits they'd meant to make in a row. And that proved really, really effective. So that's exciting and suggests something about the power of consistency and streaks that I think is really worth following up on. And this is just showing you that graphically, if you look at the pre-intervention versus during intervention performance of this condition, the extra gym visits it induced compared to our holdout control. Okay, so another winner that I think is less psychologically interesting. One of our treatments just paid people a lot more. This is, an order of magnitude, almost basically increase in payment for gym attendance. Here it was that we were paying people almost $2 for attending scheduled workouts and unscheduled workouts, like going to the gym at any old time instead of the time you'd planned. You still got paid, but only about half as much. That was very effective. probably just due to the fact that the rewards were so much larger, and that increased visits by about 25%. And here's the data from that. Another big winner was actually social norms, one of our old favorites from behavioral science. This is a study that encouraged people to go to the gym and said, hey, most Americans are carving out time to go to the gym. They're exercising more than ever before. So not only is it a norm to exercise, and this is real data sort of sliced in a way to find encouraging statistics, of course, but it's all true, showing Americans exercising a lot and actually that the rates are going up. So there's this increasing trend that increased gym visits by 24% to reinforce that message throughout the study. And you can see the data on that here. This is actually just, we tried a couple of different versions of that falling off the wagon study I mentioned a moment ago, where you get a little extra if you come back after a missed visit. There were 2 different sizes of incentives there, and both of them worked. So this is sort of like a robustness test on our best performer. Another version of that exact same treatment was one of the top performers. There weren't other studies that had this. This one we just like played with the incentive size. So anyway, just nice robustness. And then the final thing I'll highlight is a team that looked at whether or not offering people a choice and how they would like points described to them that they could earn for going to the gym was helpful. So they were given the choice to like think about and have communicated to them that every time they went to the gym, they earned points, or that every time they lost out on points, they could have earned. And giving people that choice seemed to be powerful, increased gym visits by 19%. Okay, so I only have a couple minutes left, and I want to get through just a few final details that I think are important. One of them is prediction accuracy. So one of the big reasons actually we think that this kind of study might be important is if people, this mega study, is if you don't have great priors on what will be most effective. So we as behavioral scientists feel like there's often lots of good ideas out there about how to change a behavior, but it's hard to know like which is the very best. If you feel like you can guess, you know, of a slate of 53 treatments we tested in total, I know in advance exactly what will win, then you don't really need mega studies. You can just like run that best test and you'll get a good policy result. But if you're not very accurate at predicting what's going to be successful, then you really need this kind of work. So we did a little work to see how accurately people could predict our results. And the answer is very inaccurately. So this is a pooled sample here I'm showing you. The correlation between people's predictions of how big the treatment effects would be from the study that I just showed you, and the actual treatment effect is on the x-axis, and you can see the correlation is 0. The predictors, we actually had 3 different samples predict. Some were layman MTurk workers, some were public health professors at top universities, and others were behavioral science practitioners at top organizations you've heard of that have behavioral science teams. And actually the best performers were the MTurkers. They had a very, very tiny positive correlation, and everyone else was 0 or negative. So really we can't predict what works. And in case you think like, oh, maybe the scientists who on the team who designed their studies would have better priors, they also were asked to try to predict if their hypotheses would be supported. And there was basically 0 correlation between their predictions of how efficacious their treatments would be and how they were. So we aren't good at predicting in advance what will work. More reason to do this kind of big trial. Okay, so a brief comment on the results post-intervention. I know I'm close to time, and I'm excited to take questions. I'm going to get through the last couple of things in the next 2 minutes. Post-intervention, when this is like the most interesting news, I think. On the x-axis, so every dot represents a different treatment condition. Remember, there were 54 experimental groups, 53 treatments tested. Every dot is one of those groups. The weighted average weekly gym visits during our 4-week program is on the x-axis, and the weighted weekly gym visits afterwards is on the y-axis. If there's durability in the sort of treatment effects we see, there should be a strong correlation between what happens to a group. They're, remember, randomly assigned, so they should be flat if there's no durability, but we see strong durability when we look at it on average. This is a high correlation. So like if I get you to go to the gym an extra time during the treatment period, that seems to convert to about 0.2 or 0.3 extra gym visits for many weeks after. So that's exciting. However, there were not big winners here. There were not like, oh, this really nailed it. Like most of the individual treatments did not significantly have durability. It was rather that in aggregate, you can see there's durability in an extra gym visit we induced, but only 8% of the individual programs really robustly increased gym attendance afterwards, if that makes sense. So like more gym attendance we see does lead to more gym attendance, but we didn't have big winners here. Okay, finally, let me wrap up. I'll just say the sort of big takeaways for us. We were excited about the success of the program. 45% of our treatments significantly boosted weekly gym visits by anywhere from 9 to 27% at very low marginal cost for about 4 weeks. But we're bad at predicting what will work in advance, which suggests mega studies are really valuable. Actually, I'm realizing I forgot to say one really critical thing about our predictions. Not only were people very uncorrelated in terms of their efficacy making predictions with actual treatment performance, they were also about an order of magnitude overconfident. They expected effect sizes that were wildly larger than what we saw. So that's another really important thing we noted. People were too excited about benefits. We also really see that enduring change is a lot harder to achieve robustly than temporary change, but in aggregate, we did see it happening, but we did not find runaway winners on that. We found very little that sort of on its own we could prove this treatment is really great at creating durable change after something ends, which suggests maybe we shouldn't be concluding treatments. Maybe we should, these were incredibly inexpensive. Why stop after 28 days? Probably we shouldn't have. And finally, I'm really excited about the future of mega studies to accelerate scientific discovery, compare apples to apples, reduce risk and fixed costs, and facilitate interdisciplinary collaboration. And we are hard at work right now, actually, on a massive study with hundreds of thousands of people who've already been enrolled, testing different nudges to encourage people to get flu shots, really focused on the action intention gap. And we are hoping that the insights that we gain from this mega study on nudging vaccination will be very relevant to COVID-19. In fact, we specifically chose nudges to test in this mega trial that felt like they would be portable because they were really more about sort of, sending reminders at the right moment to do something or framing it as a socially beneficial action. So we're excited to have those results later this fall or in early 2021, just hopefully in time for this vaccine to reach millions of Americans, hopefully hundreds of millions of Americans. Okay, let me stop there. Thank all of our team members and funders. I'm sorry for being a few minutes over, but hopefully you have lots of time left for Q&A.
Thank you, Katie. We have lots of questions. I'm going to begin with Eamon Colvins. How do you balance running many studies synchronously with the need for piloting? It seems like the benefits of the mega study approach also come with risks. For example, if synchronous studies all share similar flaws in the shared variables or designs, then all of that synchronous data might be void.
That's a great point. I think that's a really great point. So there's no reason you can't pilot test something if you're going to run in a mega study, just the way you would pilot test if you were going to run something else. In fact, a lot of the ideas that we launched in our mega study had previously been tested in the lab, and we were sort of saying like, oh, this is a really interesting insight. Can we take it to this field context and see if it works? And many scientists did do pilot testing like on mTurk to try to get the stimuli right and so on. So I think pilot testing is absolutely possible with mega studies, but it's also true that there's correlated risks. So if something goes terribly with recruitment or something goes terribly with messaging in some other way, you're right that it pollutes many studies instead of just one. So higher potential benefits, higher potential risks. The whole thing is just higher stakes.
Yeah, amen. That is an excellent question, and we will absolutely give it further thought. That's a great answer also. Okay, David Farrow asks, how can you compare the efficacy / effectiveness of the different interventions? Because presumably they carry different costs, like some take more time, some take less time, some may be quote unquote stronger manipulations, some weaker. So independent of their effect on the DV, is it possible to really call out winners and losers?
Yeah,
this is really fun asking you all the questions, and then I don't have to answer.
I know. I'm like, you should be answering. Angela's obviously a co-author on this work, which is under review right now. And like, we've thought a lot. We like literally sat together to write the paper. I mean, actually, well, not together because it's COVID-19, like together on Zoom, but co-writing in a Google Doc. Yeah, and Angela, actually, if you have better answers to any of these or want to take any yourself,
you go first,
please. Okay, for this one, I think this is actually pretty straightforward. So we can measure the costs very easily in this study. They're like pretty clearly, we know exactly how many dollars it it costs to pay out the incentives in every treatment arm. We know how much it costs to send the text messages. So we have that cost baseline. We had in this study, and actually in all the studies we've done, we have massive parallelism in the constraints we put on scientists. So all the studies lasted 28 days to give that comparability, and all of them, could only use text message and email and this original sign up for their communication. So it was very straightforward. It's very straightforward to do that cost benefit calculation. Of course, I could imagine like wild future mega studies where people vary, the length of their intervention. So, but you'd still be able to know the cost, and you have the same denominator available if you're doing this all through the same central organizer. So I do think the cost benefit analysis is going to be quite straightforward, and everything will be transparent, and it's much easier to compare than if like different research teams run studies at different institutions with different cost structures and so on.
And in this particular case, things were pretty bounded. So, there's not a whole lot of variation in the cost per treatment. Okay, Christoph Van Vandenbolt. I'm sorry, Christoph. Anyway, because you're here at Wharton, so I am really sorry for botching your name. How do you plan to control for the multiple comparisons problem?
Yeah, that's a fantastic question, which we spent like a huge amount of time thinking about. In the end, actually, I bet you'll hate our answer, but it's like we decided it was the best because there's so many different ways you could do it. You could Bonferroni correct, but that is like very, very, very conservative. There are like things in between. So what we ended up doing is actually zero correction, but just like publishing everything, like everything in a big table that's like, and so anyone can correct themselves. And we are very transparent, like we haven't corrected, and that is wrong. The correction you would like to apply, like go for it. Obviously 45% is not the number that we're efficacious. It's a lower number, but we can say like, it's, it should be 2.5% that we're significant. So we're confident in saying like roughly 40% really worked. That's that. But then in terms of what p-value do you think should be assigned to each treatment, you can like choose your own correction and apply it because everything's really transparent in our tables in the paper. So that's our like, after much debate, our sort of lame but very transparent way of saying like it should probably be up to the reader to decide what they think is appropriate, because we don't feel like there's just so much debate. We didn't feel like we should choose.
BCFG team scientist Gretchen Chapman asks, what is the correlation between pre-treatment versus during or even post-treatment visits look like? And I think Gretchen's wondering if that explains the correlation, the R equals 0.72 scatter plot, which is at the group
It was
level.
basically zero between, we did look at that in I hope I'm remembering this correctly. I'm like looking at, there's two research assistants who did the analysis who were like, so feel free guys, Tim and Heather, if you would like to text me if I'm messing this up, but it was like close to zero. So we were worried, like, is that 0.7 driven by, yeah, exactly what you're saying. Like there was correlation before. It was nothing close to 0.7. So I believe it was closer to 0 than 0.7. I hope that's helpful. I'm sorry, I don't have a more precise answer.
I think that's a good gist. Okay, Juliana Schroeder asked, did you measure whether participants knew about the other conditions in the experiment? For example, what if they happen to go to the gym with a friend who is in a different condition than they are in?
Yeah, it's a great question. And it's one you always have to worry about, right? In any experiment, like, is there contamination across participants? So we don't think there was much contamination in this, although we can't be positive. Here's why I am not too worried about it. A few things. One, we recruited 60,000 total of the gym members out of like 4 million plus.
Yeah.
The recruitment happened over many, many months. So it wasn't like people were all signing up together in groups. It was mostly happened digitally. So very few people signed up. Most of it was like, we'd send out an email, and that's how we got most of the people. Like emails went out and then boom, thousands of people signed up. So, and digital tends to be done like more alone rather than like, hey, we're sitting together at the same computer. And we didn't get any reports. Like we had a hotline, basically like Q&A. People could send in their questions, and that was not, people weren't raising that. But we did very clearly and transparently in our materials say like, this is a scientific project and there will be differences in the experiences people have. So, we can't be sure, but given all the things I just said, we don't think that was likely a big issue.
Yeah, and if anything, it would anyway, it wouldn't give us false positives, I think, in any case. Okay, Mikhail Strachelevitz asks, and I think, by the way, this is I'll read the question. Was there a workout for charity condition? I suspect once the rewards go away, this might carry over stronger than monetary rewards, especially with these small amounts. And my footnote on this would be like maybe mentioning Edward and Erica's article would be.
Yeah, I was going to say, I was going to make, yeah, so we did not have a study of that type, but we actually published a paper earlier this year in the Proceedings of the National Academy of Sciences, led by my amazing student, Erica Kyrgios, who's also a collaborator on what I just shared, where we ran another randomized controlled trial at the point when we paid people. So they're out of this study, essentially, it's over, but we emailed some people and invited them, if they'd like, to donate their earnings that they just accumulated and step up back to us. And some people were encouraged to treat the rewards that they had just accumulated as their own, the habits they just formed through the Step Up program as their own reward, and others that language was omitted, and encouraging people to treat the habits they'd formed as their own reward significantly reduced the number of people who claimed their cash, increased donations back to us of the rewards we owed people. And so we think that's really interesting. It seemed like people basically, and we did a follow-up experiment with it in a different setting. Basically, it seems like people are very motivated to think about what they did, not as something to get cash, but as something they did to improve their health. And when they're given that sort of out to give the money back to charity, they're very attracted to it. It gives them the self-signaling opportunity. So that paper's out in Proceedings of the National Academy of Sciences. Again, Erica Kyrgios is the lead author on it. And I will actually ask one of Heather, Tim, and Joseph, if one of you could paste the link to that paper in the chat before to everyone who's attending, that would be great, so they could have that reference.
Amit Kumar asks, do you have information on dependent variables measured like sort of closer to like the actual outcome, I think, of physical health, like calories burned?
No.
Just no.
It'd be so great if we did.
But thank you for that question. That's great.
It's a great question. It'd be so terrific if we could. And maybe, maybe in some future studies we'll have those kinds of outcomes.
Two questions that are quite similar, one from John McConnell and the other from Daniel Russman, which is essentially on the practical implications of this work for our partner. So is 24-hour fitness going to convert any of this research into ongoing engagement?
That's a great question. I hope so. They're very, we filled them in on everything. Of course, they're very excited about it. They have an app called 24Go that they have been devoting a lot of resources to building to support habit formation among their members. And we've briefed the 24Go team, and I believe they have built a scheduling tool with so to sort of incorporate the planning component that we found seemed to be effective in combination with incentives, and we've briefed them on other things that work too that they seemed really excited about. So I don't know specifically what insights they've built in beyond that, but they have been really wonderful partners and very jazzed about implementing as much of this as they can through that app. So you might consider downloading it.
All right, we have time for a couple more questions. One is from Andrew Cullen. How does this MegaStudy approach improve upon forecasting tournaments of the sort run by BCFG scientists like Barb Mellers and Phil Tetlock? Yeah,
I'm going to start to answer, but I'm going to actually pass this one to you too, Angela. I think the first answer I would give, I think they have really different functions. And I'm going to ask Angela to talk a little bit about the function of the kind of work that Barb and Phil lead that is so important. But I do think actually the fact that the predictions made in the study were wildly inaccurate suggests that forecasting what will perform well in behavioral science it's hard and may not add a tremendous amount of value. Now, I think there's almost certainly room to improve on the quality of the forecasts extracted. And there's work that we're doing with Barb on that for our current trials, and with a wonderful PhD student, Linnea Gandhi is leading that work. And so I hope in the future we'll not only advance science about megatrials, but about forecasting the results of megatrials. But the very weak forecasting results we got earlier from this study make me think forecasting so far is not a very good substitute.
Well, since you took the forecasting part, I'll just take the tournament part of the question, which is, it is a tournament. I mean, there are like foundational similarities between this and the Common Task Framework, and just the idea that synchronously many ideas get tried, and you see what happens is like a through line. And so I'll just emphasize the similarity there. We have a question about the formation of the teams. So like, how do you decide who gets into this like, elite VIP club called BCFG, Katy?
Honestly, it started as basically like everyone Angela and I had collaborated with on behavioral science research, and then we just told them to add whoever they wanted to their projects, and that's sort of how it has grown organically. To just open it to the entire world, which actually I think is a wonderful eventual ambition, isn't feasible given just given how many submissions. Like when we ran this flu shot study tournament with about 100 scientists, we got 75 submissions of ideas, and our team just doesn't have the capacity to like.
We couldn't even run all those ideas.
Yeah, we ran like 20 or maybe more than 20, something like that. But we have to evaluate and cut and figure out how to make it all work. So we started with people we've worked with a lot and knew really well already. And then we're sort of like ballooning a bit from there. And I hope, we'll continue to grow, but that's how we did it, just sort of like our collaboration networks.
And on that note, I'm going to thank you, Katy, for presenting the MegaStudy idea. I think it's really the core of BCFG's identity. So in my humble opinion, it's also a great future. I want to also say that next week we have David Rand from MIT Sloan, and the topic of David's talk couldn't be more timely, which is understanding and reducing the spread of misinformation online. But, I've got my blue mug because, the misinformation doesn't always triumph in the end. So looking forward to that talk. Katy, thank you so much. And thanks everybody for joining us.
Thank you all. Okay, see you next week. Bye-bye.